Hello my friends, today we are going to be discussing capacitors in parallel, and we are considering two capacitors that are connected across each other and then connected across a battery of voltage V. Consider also putting a switch so that you can control charge flowing to the two capacitors. So when two capacitors in parallel, they have the same voltage, but charges that are going to be stored on each of those capacitors are going to be determined by the capacitance of each capacitor. Therefore, we know these facts, that we have same voltage across each capacitor, but we have different charges on each capacitor. So let's look at an equation that gives us the total charge. So charge Q will equal to the charge stored on capacitor C1 and the other one on capacitor C2. So what happens? We know that therefore total charge will be Q1 plus Q2, but we know that charge is equal to CV. Yes, so if we substitute in equation 1, we find that CV is equal to C1V plus C2V. Factorizing out V would give us V into C1 plus C2 equivalent to CV. So when we do the math by cancelling this and that, this and that, because we have to divide both sides by V, we find that the capacitance of a combination of these two capacitors is going to be C1 plus C2. So therefore, if for example I had to replace these two capacitors, I would replace them with a capacitor, a bigger capacitor of capacitance equivalent to the sum of the two capacitors' capacitance, meaning we are able to determine the capacitance of capacitors in parallel. Yes.